Let's just get started. We're going to roll right into our first panel. So coming up to the first panel, the moderator of our first panel is Kevin Kelly. Kevin just returned from an extensive trip through Asia with his camera, where he is working on taking photos for a photo book he's producing, documenting some of the losses of culture and history in Asia as a result of economic development. But that's not why we invited him to moderate this panel. He's also a well-known author in the area of machine intelligence, and he was the founding executive editor, he is the founding executive editor of Wired magazine, which makes him really the dean of extrapolating from early stage technology, science, and startups to what that might mean for industrial change. So please welcome Kevin and the panel. Thank you for being here.
So, I'm Kevin Kelly, Senior Maverick at Wired Magazine, and I recently wrote a book that will be coming out in June. It's called The Inevitable. And part of what it's looking at is the fact that AI, among other things, are inevitable. And I think what's not inevitable is what we do with that, how we manage that, how we civilize it, and who makes money. So what I want to talk about is the fact that there's still a lot of room for what we do with AI. And the panel this morning, this first panel, is going to be looking at some of the entrepreneurs, people who are doing startups. And the way this is going to work is I'll introduce them, and then each one gets 5 minutes to do a demo. A few of them will be doing demos over here. Some will be showing demos from video. And then I'll ask them questions after each 5-minute demo presentation. And then we'll move on to the next one. And there's 6 of them, and so we have about an hour. And in the interest of moving the whole day, which is very packed, I'll try to keep things going very fast. So let me just introduce the people on the panel, and they're arranged in an unknown algorithm to me anyway. But in the spaces first is Matthew Matthew Zeeler, who is right here. He's actually going to be here, but he's going to be talking first. And Matthew's from let me get here. He's from Matthew is with Clarify, right? Right. You have it on your shirt. And the bios, by the way, are, just to clarify, exactly. The bios are in there. You have a little booklet with all the deeper bios if you want to see more. But Matthew is the founder and CEO of Clarify, and he'll be talking first. And then to your left is going down here is we have Richard Socher, who is the founder and CEO of Metamind, and then we've got Kieran Snyder, who is the co-founder and CEO of TechCEO. And then we've got Abraham Heifetz, who is the CEO of Atomwise. And next to him is Shahram Tafazoli, who is the founder and CEO of Motion Metrics. Okay, and then last we've got Derek Pridmore, right. So, and Derek is the president and COO of Osara. So that's the lineup, and each person gets 5, and I'll try to keep things moving. So, Matthew, if you could start and show us what Clarify does.
Sounds good. Thank you. So I'm Matt. I'm founder and CEO of Clarify, and I'm actually a Canadian and UAT grad, so I'm happy to be back. Clarify has a very simple mission: understand every image and video to improve life. We want to understand it with machine learning automatically, every single image and video taken, and we want to improve life. We want to use this powerful technology to do good. And I'll show you what that technology does. This is our homepage. You can simply drag an image onto the homepage. There's a quick CAPTCHA to prevent crawlers. The image is uploaded and automatically understood. The image I uploaded is on the left-hand side. The pixels of it were sent to the server, understood exactly what's in it, and returned that as 10 predicted tags that you see in the middle. You see objects like heart being predicted, and also descriptive words like love and romance being predicted. So these very high-level things only from the pixels. On the right-hand side, we retrieve visually similar images. These are retrieved out of millions automatically. If I take a personal shot that I took, this is at my cottage, and there's a black row of trees in the background that I picked out. The sun is setting over a lake. So it found all those tags, and it also found visually similar content. Not identical, not template matching, not even color matching. It's much more powerful than that. Earlier this year, we launched the same technology for video understanding. This technology understands over 11,000 different concepts, even though we're just showing 10 here. And this can be applied faster than real time on video. So what you just saw there was a URL to a video being sucked in on the server side, and that was a 3.5-minute video that happened to be understood in about 6 seconds, so much faster than real time, and in much more detail than a human could provide. So I'm just going to focus on a couple lines here. So the lines on the right correspond to mountain and snow. So if I hover over here, the height of the line is how confident the model thinks that mountain appears at this part of the video. So if I click, it jumps to a scene where there's a mountain present. And it's not very confident in snow, but maybe if I'm looking for that, I jump over here where it's confident in both mountain and snow, and I found those snowy mountains that I'm interested in. This opens up a lot of different applications in media and advertising, television, you name it. Something we just launched 2 months ago is taking this technology away from English tags and really expanding it across the globe. You can recognize these same concepts in any language. French, a couple versions of Chinese, Japanese, German. The most common languages in the world can be automatically understood. And this was crucial for some of our customers. So these are a handful of our customers that are using this technology today. You can see it's being used across a wide variety of different application areas, different verticals, whether you're powering better search like Vimeo, understanding hotel listings like Trivago, understanding wedding albums to find inspirations like Style Me Pretty, doing brand analytics like Curelate and Unilever, or building consumer applications like Vodafone and Pixar. This technology can power anywhere, any application that leverages image and video. And another really exciting thing I want to show you guys today is called Forevery. It's our new application we just developed, and this is the first time it's been publicly shown on stage. So I'm going to jump to a quick demo from my phone here. Please, everybody with an iPhone, take it out and download it right now. You can actually get access to it in the App Store, and it organizes your personal photos using this powerful technology. We built people facial recognition from scratch, so now you can tell it your friends and family, the people you care about most, places based on the GPS of these images, or things. These 11,000 different things, very high level, like summer. You can get all those summer shots that you care about. Let's see, interesting objects here, food, etc. And all of this is powered by search. So if you're looking for something like maybe you want those beach shots in Jamaica, something really specific, you can find anything you're looking for. But we went one step further. We knew 11,000 categories wouldn't cover everybody in this room's use cases. Things like the name of your pet, you can teach it on the phone. It learns. We built the machine learning into the phone so it learns from you. Your high school basketball team, the Barons, your favorite car. Anything you care about, you can teach it, and it'll automatically learn. And finally, it builds these into stories that are very quick to share with people you care about most. They're interesting memories that with one touch, it'll pull up the people that it thinks are most relevant to share this to, so it actually learns your habits over time, and in one click, I can fire that off to my wife. So this is Forevery. It's available in the iOS App Store, and it furthers our mission of understanding every single image and video in the world to improve life. Thank you.
So that's really fantastic, Matthew. So who are your first paying customers? Who do you see your first paying customers to be?
So everybody you saw on that slide are actually paying customers today, and there's many more than that. These are large enterprises across different verticals. We see a lot of traction in brand analytics. They want to understand how their brand's being talked about in the real world on social media, consumer applications, whether they're building them in-house or have them already out there that you just want to augment with intelligence. Lots of different application areas.
And how do you price it? How do you sell? What is the metric that you are measuring in pricing things on?
Yeah, so we offer this technology up as APIs. So with 3 lines of code, you can actually integrate this technology with your application. You basically import our API client, you authenticate with our API credentials, and you tag image or video. So that makes it really easy, and what we do is charge based on the API calls. So the more calls you make, the cheaper per call it gets.
Okay. And are you imagining at some point going directly to the consumer and charging them for some of this work, or is this something that is going to be going through an enterprise?
So our first consumer product is Forever, which we just announced last week, and that is free for now. We don't have any monetization within the app, and there's no near-term plans for that. We really wanted to get this technology in front of everybody, build some brand recognition around it, and it's really fun. We wanted it ourselves.
Okay. And as you imagine, where will you be in 5 years? Where do you think you would like to be in 5 years?
That's a good question. I think we've seen this happen before, kind of with companies like Google that started off with a core technology. We started off with image recognition, and we ended up being the best in the world at the end of 2013. And from there, we've been expanding it in more categories, making it now more personal. And I think continuing to grow in those dimensions is going to be really important. And staying as a platform that can apply it to every possible vertical is important to us because we know there's lots of relationships between verticals and lots of different application areas for this technology, and we want to capture all that.
And do you have revenue right now? Are you actually making money?
Yes.
That's really great. So does any of the other people on the panel have a question for Matthew? No. Okay. So I think, thank you, Matthew. I think we'd like to go to the next one.
Thank you.
Good.
All right. Hello, everybody. There's some great gigs to follow today. So we're Metamind. I'm the CEO. My name is Richard. And at Metamind, we like to bring custom enterprise-grade AI solutions to you. So what do I mean by this? AI, for us, is largely understanding visual and textual input. So there's some overlap to what Clarify does. Let me give you a couple of examples. Here we have, for instance, a food classifier. It's what we think is the largest and most accurate food classifier in the world. And we started building this classifier because a lot of customers asked us for diabetic patients that they have, or for fitness applications, or for just foodies. It's very popular in the United States to be able to categorize automatically their food. So you can, for instance, have here a strawberry picture, or you can upload your own pictures, for instance, of pad thai. And of course, as a company, you would integrate this into your app. So this one here, we still have internet. All right, well, that's the problem with the upload. Here we go. So you have different pictures. We may have trouble with the upload speed here on the Wi-Fi, but those pictures are online. So here, basically categorized as an apple pie, and if you later want to keep track of how many calories you eat and so on, it will help you do that. But we realized that it's hard to build a single classifier that will capture all the different use cases that you have. We have customers now, including in healthcare, that want to classify very specific problems in lung CT scans, for instance. So we also enable you to train your own classifier with a simple drag-and-drop menu or a simple API. So we can literally, right now, together, train a classifier. So imagine you're a company in the car space, and you want to essentially automatically find where people show pictures of your car on social media, and then what do they actually say about it. So here I have 3 different car categories: Audi, BMW, and Tesla. I can give it 3 different classes. Got to include Tesla since we're coming from Silicon Valley. So here I show you basically, I train the algorithm with 13 different pictures of each class. And then I can give it the name. I give it a car brands classifier. And now I can send these pictures to the backend and our GPU-based architecture, and we'll essentially then train an algorithm. And before people started using the Wi-Fi much, 10 minutes ago, that worked very well. So generally, if you have good Wi-Fi, it'll be done in about 10 seconds. And then you have 3 lines of Python code that you can then use to essentially classify your images. So let's see if the Wi-Fi will be in our favor for just one image. It is still very slow. So generally, it takes only a couple of seconds to classify, or not even a couple seconds maybe to upload if you have a slow connection, and then a few milliseconds to classify your image. Now, a lot of people use these for very different applications, and we see, like it was said in the introduction, a lot of different use cases. Anything from the fashion industry to classifying blood cells in mobile apps, to classifying company logos, for instance, or here the car classifier I just showed you. Now, not everybody uses images in their enterprise, so we also started working on natural language processing applications and actually have done some research even in that space. Here's an example of a new algorithm we just introduced last week to the academic community that it can actually logically reason over different kinds of inputs. So maybe if you saw these different applications here, or these different sentences, you might be able to reason and answer this question of what color is Bernard. And the interesting thing is the model did this exactly the same way that you might do it, which is going sort of intransitively reason, realizing Bernard is a frog, knowing that this is not enough to answer the question, then going to Lily, also being a frog, and Lily's yellow, and then it realizes, now I know the answer. So it can essentially logically reason over this, and folks who have complex customer relationship problems and want to do automated customer question answering are very excited about this kind of technology. The interesting academic breakthrough here is that we can essentially reduce every natural language processing problem you might have in your enterprise, not just customer questions, but also understanding the sentiment of what your customers actually hate about your product or love and talk about on social media, by reducing all these different problems to essentially question answering problems. So this is also the most accurate model for sentiment analysis. So you can say, for instance, a tough sentence like, despite the glowing reviews, this movie wasn't an especially engrossing experience. And despite having mostly positive words, this algorithm still understands that this is a negative sentence. And all we had to do is train it with a lot of triplets of, here's an input, this is the question, what's the sentiment, and here's an output. We can also do a more linguistic task, like part-of-speech tagging. We can find named entities in sentences. We can also ask, what is the translation into French? And then it will translate to French. And last thing to show, because once you know both language and visual inputs very well, you can also combine the two and actually find one from the other. So I can type in bird, and it shows me pictures of a single bird. But I can go to birds in plural, and it actually has learned that birds in plural look different. And birds on water look also different to birds in trees. And so this model has gone beyond just giving a single label to your image, but actually has understood the compositionality of how meaning forms to have more complex understanding and complex visualizations of concepts. All right.
Thank you. So Richard. That's amazingly complex and it's very sophisticated. So again, in terms of the market and the business for this, who do you see as your customers, or who are your customers right now?
Our first couple of customers are in the vision space, because we only had our NLP breakthroughs this summer. The first one is actually VRAD, Virtual Radiologic, which is the largest teleradiology provider in the United States. And our first application of them is to classify intracranial hemorrhage, brain bleeds, and head CT scans. So they work a lot with emergency rooms and essentially want to understand and be able to it's very, very likely it will kill you in a very short amount of time.
And how do you charge? Is this an API again, or do you have a site license?
Yeah, so we actually have different models. Right now, the website that I showed you is completely free. With VRAD, we have an agreement where they essentially pay some amount upfront for developing the technology, and then there's a licensing and support model behind it. And then the other customers, to answer your first question, are more in the e-commerce space, real estate, the food.
One of my assumptions is that AI becomes a commodity, and it becomes something that is like electricity, that is generated at large scale and then just sold. So do you agree with that, and how would that affect what you're trying to do?
That's a great question. I do think AI will get, and is getting, commoditized, right? It used to take you a supercomputer many years ago to try to build an image classifier, and it still wasn't very accurate. Now, you just drag and drop some images into your browser, and it's free. I mean, we're very much taking huge steps into the commoditization direction.
And would that change your business if it did become a commodity?
Hopefully, we're the provider of that.
Okay, great. And another thing that I'm curious, because I've been watching your work, and it seems to be going very faster. Do you have a sense of the rate of progress in AI? Is there a metric that you're using internally? Are we at the point now where there's kind of an exponential rate of progress? And if so, what is that metric that you're using?
It's tough to put a real metric on the overall progress on AI, because what is AI? It's artificial intelligence, but what is intelligence, right? It's hard for us as humans to define it. Some people assign a lot of monetary value to motor intelligence by, hitting small balls into very small holes very far away. You can make millions with motor intelligence, more so than other people with other kinds of intelligence. So intelligence is tough to define, so it's tough to define sort of a number and say it's exponentially growing. That being said, it's clear that we're making huge improvements in this space. Understanding images has been really hard. Getting so many accurate, different natural language understanding problems solved in such a short amount of time is, I think, unprecedented also. So we're making huge progress.
So thank you, Richard. I really appreciate it. Thank you. So let's go to Kieran. So again, Kieran Snyder is from TechCEO.
I want to use the podium PC because the Wi-Fi keeps having issues.
And by the way, anybody who knows, doing live demos is like really, really crazily dangerous to do.
Awesome.
Yeah.
Okay, can everybody hear me? Yes. Okay. I'm Kieran Snyder. I'm the CEO of TechCEO. I'm going to take you on a journey about text today. You're going to see up there is our TechCEO home screen, and I'll walk you through it. How many of you, no matter what business you're in, whether you work at a university, you work in technology, you work in government, you work in finance, I bet the thing you produce most of every single day in your organization is text, right? Whether you make hamburgers or widgets or computers, text is actually the main thing you produce. So our premise at TechCEO is that what if for every business document you write, you could know how it would perform before you ever published it? What if every time you're writing a business document, you're getting feedback specific to your document type to make it great, right? Imagine spell check, but exploded by machine intelligence, so that when you're writing an email, you get the perfect feedback. Make that email to your boss land successfully. When you're writing your marketing website, you're getting the perfect feedback on that copy so that customers are going to engage. When you're writing a job listing, and I'll ask, how many people in this room have ever written a job listing? Anyone? How many have enjoyed it? Only me. Our first application in TechCEO focuses on talent content, and I'm going to show you a little bit about how it works. So imagine if, when you set out to write your job listing, you have certain goals in mind. You want to attract qualified people, people that are good enough to interview. You increasingly, especially in technology and finance, want to attract a diverse mix of people. So at TechCEO, we began about 15 months ago collecting lots and lots of data. Data for us initially was a job listing and then information about how it actually performs in the real world. And then we look for patterns like any machine intelligence company. So I'm going to show you how it works. Today, by the way, we work not just on job listings. We've extended into email as of a couple of weeks ago, but I'm going to show you the job listing application. So up here you have the TechCEO home screen. You'll see it looks just like a word processor. We like to say that if you can type and you can hover, you can use TechCEO. You don't need to be a machine learning expert or a linguist to do so. And over here, I've picked a job listing right now on the Amazon website. And I can pick on Amazon because it's the last place I worked before I started TechCEO. So let's go ahead and take, sorry, I'm not used to Windows controls. Go ahead. So this job listing is for a front-end engineer. Whoops. It is a job listing, not an email. We've picked the type of job. It's an engineering job. And this job is in Seattle, which is where we are from. Whoops. Seattle. That's what we want. I'm specifying these things because, as you can imagine, the guidance you would give for a job listing to attract a great front-end engineer in Seattle might be very different than the guidance you would give to attract a great barista in Toronto, right? So the language is a very local and specific thing. We're going to go ahead and we're going to paste in the job listing. I'm going to make it a little bit bigger so people can see it as well. And you see that it gets marked up. And the very first thing you see is you get a score. This is a score out of 100. So this is not super strong. We model 3 metrics with this score. This means that compared to all similar job listings that TechCEO has seen, and we've seen listings from over 10,000 organizations at this point, it's several million listings added to every week that get tagged with information. This is going to attract fewer people. It's going to attract a lower proportion of people that you actually want to interview. So based on the resumes submitted, you're not going to get people that you really like for this job. And the role is going to take longer to fill, so not super strong. You can see that we have highlighted some of the text with different colors. Green language is language that statistically, when you see a lot of it, it drives up the score. It means this is a really effective listing. You can see this doesn't have too much. I could hover over, probably very hard to read in the back, but we give you some exposition as to why this is strong.
So, Kieran, you have about a minute. I just
Okay.
wanted to...
Yep. Red phrases are phrases that statistically drive down positive engagement with the score. So if I hover over and I say, instead of saying successful candidate must have a strong drive for results, if I wanted to go ahead and edit this, I could take that out and just say, you have a strong drive for results. TechCEO will detect that I've made a change, and you can see I've picked up a few more points for that change that I've made because statistically, formal language performs worse. We look at gender bias. We've been covered quite a bit in the press for gender bias. We look at the patterns of language that correlate to attracting proportions of men and women, respectively, to a role. I won't show you the edits there in the interest of time. Blue and purple represent masculine and feminine language. We look at structural characteristics, so we don't just look at the n-grams and the words, but we look at things like how much of this content is bulleted. Turns out you want your job listings to be about a third bulleted. So we look at visual formatting characteristics. We look at syntactic elements. Turns out things like the blend between active and passive language make a big difference. We look at semantic considerations. Do you have an equal opportunity statement? Do you have a strong benefits statement? Any of you can go try this. One of our big real principles is that the experience is friction-free. So any of you could go, if there were Wi-Fi in the room, to our site right now, and you could be using it in 30 seconds. So encourage you to try it out. Lots more I could show you, but this is the essence of it. Imagine job listings times every business document that you write, and that's what we're doing.
Thank you.
Yeah.
Good. So some questions. I'm curious. So right now, I guess you would sell this at the enterprise level to a company that is doing a lot of hiring.
Yes.
So are you making revenue right now? Is this?
We are making revenue. We commercialized in July. We have a number of Canadian companies who are subscribers, some of whom are in the room today. Royal Bank of Canada just subscribed. We're really excited about that. But we do. Most of our enterprise subscribers are large tech and finance enterprises, about 2/3 of our enterprise subscribers. We've had about 2,500 companies use TechCEO so far in our first. I'm happy the investor who invests in our company's eyes just got very big when I said that. But about 2,500 companies since we launched our beta in March.
And have you ever done a calculation of sort of what the premium is for a smart ad? In other words, like,
Yeah.
So was it a 10%, 20%?
Yeah. So job ads that go through TechCEO fill an average of 20% more quickly than those that do not, and attract between 12 and 15% more applicants from underrepresented groups. So the ROI is quite strong on the use of the product. So we just launched in TechCEO for candidate email. So sort of, hey, Siobhan, I saw you on LinkedIn. Please come work for my company. And we're already seeing just in the first few weeks of usage there a lift in candidate response rate.
If you could have access to an AI that was 100 times smarter than the one that you're using, how would that make your product 100 times more valuable? I'm wondering what the kind of gating factor is for your company in terms of AI.
So I don't think the gating factor for a company like TechCEO is in core AI technology, although certainly technology innovations only benefit us. This is fundamentally, like many machine intelligence companies, it's a data question. So how rich is your data set? How highly tagged with specific outcomes is that data set so that you can learn the patterns that actually make a difference for users?
And what was the most surprisingly difficult thing that you've encountered in the last year or so in trying to do this?
Oh, goodness. They're not technology things. They're all, the company is about 15 months old. So we're young compared to the companies here. And I probably have a book of things that I wish I'd known when I started as an entrepreneur. And everyone up here will nod because they know them also. The technology is not the most challenging part of starting a company. I come from an enterprise background. I have a PhD in computational linguistics, so I knew the academic world. I worked at Microsoft and Amazon. Distilling everything down to startup scale where you're doing everything yourself is for sure the most challenging part of getting the business off the ground.
Well, thank you very much. I really appreciate it.
Thank you.
So, next up, Abraham Heifetz, and you're going to present right from there? Yes.
If I can.
Okay, great. With Atomwise.
Great. Good morning. So Atomwise uses artificial intelligence to help discover new drugs. And what you're watching on the screen here is actually some data from our Ebola project, which I'm going to talk about later in the presentation. And so you can see how the computer here is assessing, trying different drugs, how they're going to fit to the Ebola virus. So this is the part of the virus that actually enters healthy human cells. And as you can see, we can do it pretty quickly. We can assess about 1 million molecules a day. And that's really important because, if the thing goes, today for discovering a single new drug, it takes 15 years and about $2 billion. And part of the reason why is because when we do drug discovery, we have to test millions of molecules, and by far, the vast, vast, vast majority absolutely fail. So if we had a better way of assessing the technology, what we're capable of doing is predicting which molecules are worth checking, worth running the experiment on. And so you can make the predictions which ones are going to be effective and which ones are going to be safe. Today, answering the kind of questions that we're answering take millions of dollars and months or even years, whereas using this computational technology that I showed you, you can get the same kinds of answers in thousands of dollars and days or weeks. So that's really exciting from a societal point of view, the impact. But beyond that, actually, it allows us to work through a whole range of different types of diseases. So immuno-oncology studies, malaria, multiple sclerosis, both the kinds of diseases that we worry about here and the ones that we worry about around the world. How do we do it? What we've talked about is that deep neural networks are the really popular kind of machine learning today, is really good at taking pixels and classifying that as containing a dog or a cat, or taking speech and telling you whether you said cat or car. And we take biochemical information and predict whether that's going to be an active drug or an inactive drug. So you may have seen things like this before where, just one slide on the underlying technology, the deep learning learns how to which features are important to look at in images. So out of the raw pixels, it combines those into edges, and then those edges into eyes and noses, and then those into faces. We can show that actually we can do the same kind of analysis in compositional, hierarchical composition for biochemical features. So just out of 3D atomic coordinates, the network automatically learns chemistry. And so it looks for things like different chemical groups, aromaticity, single bond carbon, and so forth, and then puts those together into the prediction of how that drug is actually going to work.
1 minute.
Okay. So that allows us to predict which molecules are going to work against a target, which molecules are going to hit targets that cause toxicity. We can talk about which drugs currently exist that can treat new diseases. And so a couple of examples. This was a C. diff, which is a hospital-acquired infection that no one wants to get, new antibiotic. In a day, we got exactly the same answers that took wet lab screening 5 months. And if you remember that a blockbuster drug, a day of sales for a blockbuster drug is $3 million, you can see that the impact can be quite dramatic. This is what I talked about for the Ebola project. We took all the drugs which already had human safety data, and we found one which stopped infectivity in cell culture. And so that's ready to go into mouse testing in the Winnipeg National Microbial Laboratory. And then the last example of multiple sclerosis. This is a case where there are no good treatments for it today. We assessed 8 million molecules, took us about a week, and we found a compound which is orally active in mouse. Now, I'm not a biologist, but I think you can see the mouse on the right, which is a mouse model of multiple sclerosis, dragging hind limbs, limp tail, versus the mouse on the left, quite a happier mouse. And if you prefer statistical separation, that's the chart on the bottom.
Okay.
There we go.
So,
thank you.
Okay, great. So, what's the business model? How do you price? I hope you're taking a slice of the billion-dollar drugs.
Yeah, so that's the interesting thing. Here we're talking about market implications for AI. And so one of the interesting things is that because our work is so much faster as enabled by the machine learning, it means that we don't have to be a traditional biotech and run a single discovery project or maybe two. We can run hundreds in the same resources. And so actually what we do is we can build out a portfolio of drug discovery projects and essentially build an index fund of new drug discoveries.
And so are you generating revenue right now?
Well, so that model also has the consequence that the upside is deferred into the future.
Okay. And so it really wasn't clear to me whether your program or software was being at the level where a biologist could actually use it, or do you have specialized technicians that must set up the query and the process? Or is this something that any kind of off-the-street biologist would be able to use?
Sure, great question. So it's funny. I've had the conversation with biologists. I use my computer for email and writing grants. And so I don't want to touch a computer. So they prefer, yeah, exactly. So they prefer using us as the user interface. Okay. And that would be in your model then, is that you actually are doing, the people that work for you are doing the work, and you it's not an AI for consumers then, in that sense. That's right, exactly. So we work with really smart biologists who say, if I could only hit that protein, then we can stop multiple sclerosis, or we could stop Ebola, or we could stop cancer, or we could stop diabetes nephropathy, just to give a list of a couple of the projects that we're working on. And then they don't know what could stop it. So then we assess all the molecules that you can buy, or even more molecules that you can conceive of, and we say, here's the 20, here's the 50 that you should bother testing. And if AI is increasing at the rate that it seems to be, and you have 10x, 20x improvements in the next year or so, does that
make your job 20 times easier, or is AI not the gating factor?
Sure. So there's lots. Number one, there's scale, which is horizontal across diseases, right? The kind of technology I'm talking about here is general enough that it's applicable across a wide range of diseases. The other way to think about it is you can penetrate and address more of the problems in drug discovery. So here I'm talking about which molecule should you bother assessing, but don't you want to know if it's going to be safe up front, right? And then filter anything that's going to cause difficulty. Now here you still have to incorporate the biologist, right? Because what's safe for an acne cream, the kind of side effects you're willing to put up for an acne cream or a treatment for diabetes, which you're taking for the rest of your life, those are different than the ones that you want to take for an infection, which you're taking for 2 weeks, or cancer, which you want to be done with.
Well, thank you so much. We really appreciate it. So next up is Shahram Tafazuli. So please, from Motion Metrics.
Yes, hello everyone. I'm presenting Motion Metrics here, extending machine intelligence. So what we do is to install camera and sensor-based systems for tough mining applications, challenges that are unanswered. So that picture shows our embedded computer, rugged camera, touchscreen display, and other sensors that go on the machine. Shovel Metrics is our standard system on large mining shovels. There's about 10,000 of these around the world, making all the commodities out of open face mines that produce iron ore, gold, and other things. We install a camera system. We have a large number of systems out there in the world that does many things, from missing tools detection to collision avoidance. My focus in this presentation was on fragmentation analysis. So in that picture, you see that bucket with full of rocks. The idea is, what are the size of those rocks? There's about, in that particular picture, there's 100 tons of rocks in that bucket. So equivalent to about 100 cars. And how can we automate that process? So keep that in mind. I'll move on. And loader metrics, we install a camera under the bucket, which uses thermal vision because the teeth get hot. So we have been using deep learning to identify if a tooth is missing or not, because that's such a big headache and a big safety concern. However, there's also a camera that is looking at the face. So as the loader goes to dig the material, we take a picture, and then again, question is, what is the size of those rocks? Belt metrics, similar concepts on a conveyor belt. Tons of rocks are passing through. System does multiple things, but the main question is, those are rocks that have gone through a crusher, smaller size. How do I measure those sizes in a regular manner? Just imagine the camera takes 10 pictures a second, and there's tons of material going through. And how are we doing with the sizes? That's the main theme of my discussion, my presentation today. And in this picture, we show Portametrics is our newest device. I do have a sample here. This device uses a stereo vision for 3D sensing of the world. So you can essentially hold it in the mine, look at the scene, take a picture, and in a matter of half a minute, 30 seconds, know the rock sizes right after the blast. So that picture shows the previously how it was done, before and after. Before, the miners, they would put basketballs in the scene and use the camera system to go and take a picture, or underground, you see over there. And the idea with the Portametrics is get rid of all of those, do it fast rather than a 2-hour job, 2-person, unsafe, make it safe, and perform it very fast. So this is using a stereo imaging, but my focus will be a little bit, as I go through the presentation, how we are using deep learning to help us with this very tough problem. So big data and cloud computing, all these devices on the shovels, loaders, portable, and on the conveyor belt, they are all generating very useful images and data. We connect them to the cloud, and anywhere in the mine you can have access to that. So unlike all the other, Google and Facebook, where humans are generating products, here are machines that information is coming from. Rock fragmentation, size of rocks is very important. Take my word for it. In the very beginning, after blasting, you want to do a best job because as you go further down the crusher and the material sizes get smaller, the more expensive it is to do that job. So above the ground, underground, everywhere you want to get an idea, and this is worth millions of dollars. So we tackled this problem. In that picture, you see a good number of people. What are they doing in my company? They are labeling rock images. So they take an image like that, which I show here. You see big rocks, small rocks, shade, and sun. Tough problem. It seems easy, but we tackled this problem. But here's the result with standard machine vision after 10 years of working. You see that there is over-segmentation, under-segmentation happening. That's not proper measurement. That takes 40 seconds. After some manual corrections, which takes 6 minutes on this, the result is that, and that's very accurate. So this is 6 minutes is already disrupting the industry, which used to take 2 hours to do the same job. However, a human, this is the result of their work. This would take 4 to 8 hours in Photoshop to do. Tough problem, but human brain is amazing. You see the result, big rock, small rock, fines and all that. I want to show you a work in progress, how we have been using deep learning, doing this job in a matter of 1 second. The image you are seeing there is showing the same image processed by our deep learning algorithm in terms of probability map in 1 second. So I will wrap up my presentation with saying, what's my dream? I have a dream with our systems that you can get rock fragmentation accurate fast, anywhere that you want, anytime. And deep learning is making that possible for us. And this is just one angle of the work we are working towards. And the idea is down the road to be a mini Google of mining. For all the mines around the world, we gather the big data information and process it with artificial intelligence. Thank you.
Thank you. Okay. So, Sharm, as I understand it, that you did have people doing this job at one time. So now, is this a case where you're replacing people with AI, or is this something the AI is doing a new kind of job that the people can't do at all?
Yes, it's a very tiring job. It takes a long time, and nobody can do it as good as humans up to today. However, our goal is to replace human being because such a tedious job, and the amount of images coming in is just amazing. On a conveyor belt, I was talking, is like 10 times a second, and in all those devices. So if you had that information almost immediately, the value goes so much higher. And honestly, this is a traditional business. Nobody believes that we can do what we are doing today. So the idea is to replace tedious stuff.
And the AI algorithms you have, is there a mechanism for the second order of learning where it gets better after it's done 500 of them? Does it actually learn how to do it better?
Exactly. Right now we are using a few hundred images in this example of fragmentation. And it's almost, you know how AI, the idea is to copy human performance. So in these first 100, it's very important to do a good job. It's almost like, you know, the kids learn from you. So you have to be very careful in the early ages they are learning that they are going to be copying you. So you want to make sure you do a good job. Same thing here. Those initial images we need to make really good jobs so that the computer doesn't learn the wrong way.
Well, thank you so much.
Thank you.
So last but not least is our last speaker is Derek Pridmore with Osara. So, Derek?
Hey, guys. This is a much better looking conference than NIPS. Congratulations. So my name's Derek Pridmore. I'm one of the founders of cero. We're a machine learning company based in San Francisco, and we are productizing deep reinforcement learning. So you guys have heard a little bit about deep learning up here earlier today, so we'll hear a little bit about reinforcement learning. So we're focused on action.
Could you use the mic closer?
Sorry about that. Yeah. We're focused on action. So our mission is to make robot control fast and easy, and we're doing that with deep reinforcement learning. Our team has experience in machine learning. So Itamar is a machine learning researcher. He's been doing deep and reinforcement learning research for 10 years. He's also a serial entrepreneur and founded one of the first, and I believe first profitable deep learning company called Binatics. Michael Kahane is an industrial engineer. He has experience in high-performance signal processing and embedded systems. My background's originally physics and computer science. I became an investor for the last 10 years in public and private markets. In particular, when I was a venture capitalist, I focused on deep learning. And at Founders Fund, we were able to lead DeepMind's Series A. So that's a company that was acquired by Google. Sorry, I can't even see my own slides. So what's the market? Industrial manufacturing. So it's a huge market. There are around 2 million installed industrial robots in the world. And they're selling actually more than 200,000 units a year. So it's a huge, huge market. The hardware systems is over 10 billion. The value of the software and the integration is over 20 billion. So what's the problem? Oh. Yeah, that's fine. So the problem is existing robotic control solutions are very fragile. So how does it look? What does deploying an industrial robot look like? Typically, you're going to buy a robot from a manufacturer, and you're either going to hire their engineers or an integrator to come in and do a custom program. They're going to analyze your production process, look at the product you're building, and design a custom solution for you. This could take weeks or months. And that used to be fine when you would run your manufacturing line for a year. But there's a move in the market towards something called mass customization. So you have smaller production runs. And that month is now a limiting factor. So they want that to be fast. The other problem is that they are inflexible. So they're not robust to noise. And this is an issue today because if you want to make this for less than $100, you have to use the crappiest components possible. So if your part has slight variations in size because it's not precisely manufactured, or slight variations in orientation, existing solutions just fail. So you actually see these manufacturers putting lots of work into augmenting their line so they can make sure the components are precisely aligned. The big problem, again, is it works until something's just a little out of place or you need to change your line. So they're slow and inflexible to deploy. So mostly what manufacturers do if you're doing a shorter run is you use people. You throw people at the problem, but labor costs are rising. So all of these things are forcing these guys to try to find new ways of deploying and controlling robots more quickly. So,
1 minute.
Sure.
Okay.
So deep reinforcement learning is a
And hold your mic up, please.
Sorry about that. So you guys have seen deep learning earlier today. Deep learning is a way of doing automatic perception. Reinforcement learning is sort of the action version of this. It automatically learns how to control things. So deep reinforcement learning puts these two things together. So it sounds like a great solution for robotics, right? There's just one catch, which is that it's very slow to train. So some of you may have seen examples of, in DeepMind's case, they built an agent, which is what we call these algorithms, and the canonical data is playing an Atari game. So it learns how to play a bunch of different Atari games really well, and it achieves superhuman performance. But what most people don't realize is that the actual number of games it plays to get to that performance is huge. It can play 10,000 games. Now, obviously, humans learn much faster than that. We bring a lot of knowledge to bear on the situation, but we also learn from mentors. So our philosophy at cero is to continue to take inspiration from nature, where you're almost always either born with an instinct or you have a mentor.
30 seconds.
Sure. So here's an example, if you hit play, of naive deep reinforcement learning. Again, it's learning from pixels. It doesn't know anything about the game. It's just watching the game, has access to the controls. This is 10 games in. So this is after trying to learn for 10 games, the naive way, from scratch. It's terrible, obviously. It doesn't know what it's doing. It will continue doing this for thousands of games. So actually, if you can go to the next slide, I can't. Cool. So this is cero's technology. So we've built something called imitation learning, where, again, it's still looking at pixels, but it watches you play one game, and that initializes it. You don't have to play well. You don't have to play perfectly. And then it starts learning from there. So this is our system after watching one game. So you can see it's missed a few, but it actually kind of knows what it's doing. It knows to go after the ball. And this is after only 10 games. So this is the future of deep reinforcement learning. It's going to be combined with imitation learning, and humans are going to actually mentor machines. You can demonstrate for the machine what you want it to do.
So I have a question. When you say watching, is it literally watching in terms of
it's literally watching the pixels.
Is it camera pixel?
It's not camera pixels. You're capturing from the screen, but it doesn't know what you're doing. It's just seeing the result of your actions.
Okay.
So you can actually go to the next slide. This is actually an old slide, but it just shows, on this axis is the number of games, and on this axis is score. This is in Pong. You can see that this flat line here is naive from scratch, tabula rasa, deep reinforcement learning. And all the other lines are versions of our technology. These are actually all old. It learns much faster now. So you can go to the next slide.
Okay. So,
just final slide. We're working on applying this in robotics now. So we're working in a simulated environment called Gazebo, and we're partnering with industrial robot manufacturers to build physical versions of this.
and when your system is watching a robot, it's actually again using camera eyes to watch how the robot, rather than taking the data from the robot, it's actually visually watching them?
So right now, the best working example is still on this ALE platform, and it's seeing the pixels, but there's no camera looking at the screen. We're just pulling the pixels off the screen. But it doesn't know, for instance, what buttons you're pressing, and it doesn't know anything about the game. It's still learning everything from scratch.
And how are you charging for this service?
We haven't charged yet.
Okay.
We envision something like a robot as a subscription. Basically, we think of it as we're building minds that are going to power these robots, and it's going to be a subscription service. So these robots typically cost around.
Could you put your mic up?
Yeah, so it would be something like a subscription service.
Okay.
These robots typically cost around $60,000, and integrating them can cost $100,000 to $200,000. So we envision something like $5,000 a year per robot per machine. Per machine per year.
And is the intelligence cloud-based, or is it going to be embedded in the machine itself?
I mean, it's probably going to be local. You could do it from the cloud. I think the long-term goal and things that people in the field are thinking about are transfer learning. So it would be great as if you have a robot in China optimizing some process, and once it does, you want to update your robot in the U.S. So you can definitely have sort of a network effect if you can crack the transfer learning problem. But initially, customers might want to just train their robots locally and keep the information local, because that's part of their IP, and so we would allow them to do that.
Okay, that sounds great. Does anybody on the panel have questions for any other people on the panel before we close?
Maybe.
Yeah. Okay. There you go, Richard.
TechCEO, are you able to use machine learning to give better recommendations for improving the text?
Yes, it was probably hard to see in the demo, but that's exactly what you do when you hover or you click on the sidebar. It tells you what to do to make the improvement, drives the improvement in your score, which in turn improves the ROI on your document.
When you make a suggestion, how did you write out the text of how to improve something?
That was a lot of work. We can talk about it offline, but that was a lot of work. For me, so...
Wait, repeat the question.
He asked, how long does it take to train TechCEO for a new kind of document? And the answer is it depends how much data you have. Most of the core systems, or the core NL libraries, the core approach to our learning algorithms is obviously shared across document types. But when you head into a new document type, sometimes there are new features to learn. So generally speaking, if we have a reasonably sized data set, we're trained in a few days, in terms of all up time in the engineering team. Yeah. Yes. Could we train it to analyze machine learning?
Repeat the question, please.
Could we train it to analyze machine learning research papers? Yep, and Kickstarter campaigns and real estate listings and VC pitch decks and love letters and course syllabi. All of these are things, because it's basically just a box. So all of these are things people try today. And of course, we are trained on talent content, so we do best on talent content. But it's the great thing about what we're doing is our users tell us what they want to see next. So the reason we launched TechCEO for Email Next is because 10% of the content coming through the system was already email. So that's a really good indication that that's something people want to do. Ajay is like, enough.
Right.
No.
In the interest of time, there was lots of questions. The panelists will be here for the rest of the day. There is a really fully packed day, so I'd like to give our thanks and applause to everybody up here, and we'll move on. Thank you.